The above expression can only be differentiated by using the product rule. In other words, we need to have a look at this expression as a product of two functions, one which is in blue, root x, and the other one which is in red. And we'll call the blue function u, and we'll say that that is root x. And you may rewrite this as x to the half, and when you differentiate it, it will be 1 over 2 root x. And it's probably best that you memorize this without going through the intermediary steps. And the second function we'll call v, and that is 3 minus x to the squared. Now this one needs to be done by chain rule because it's a composite function. So when we differentiate this one, we'll get 3 minus x to the power of 1, and then we'll just need to multiply it by minus 1. And this gives me minus 2 brackets 3 minus x. And the rule for the product rule is that we take u dash times v plus u times v dash. So we'll just substitute these in. And this is adequate, but we are asked to show that we want to make dy dx into this form over here. So you can see that in the denominator we want to have 2 root x. So it would be advantageous to put a denominator of 2 root x. First of all, try and see it as this. This is one part here, and we're adding this part here. And if I rewrite this, it will look a little bit like this. All this is squared over 2 root x, and then this part over here is root x, or should I say minus 2 root x 3 minus x, and underneath over here we've got 1. Because I want everything to be over, I'm going to multiply this by 2 root x, and therefore I'll multiply this bit by 2 root x as well. And we need everything under that denominator of 2 root x, 2 root x, and above we've got 3 minus x all squared. That is a minus sign over here, which we'll put down here, so that will be minus. Now we have also a 2 and a 2 there, so that's 2 times 2 is 4, so we'll say that that is 4. And now can you see we've got a root x and a root x. If you multiplied root x and root x, we will just get root x. We'll just get, x. So we'll have x, and we're left over with the 3 minus x. And the way we want to proceed this is we want to have a look at exactly what is it that we want to do. They want you to put 3 minus x, a product of 3 minus 5x. So I'm looking at my numerator over here, and I want to see how I can get to that particular part. Well, let me just rewrite this, and you may note that 3 minus x squared is really 3 minus x, 3 minus x. Then we have minus 4x and 3 minus x, and everything in the denominator is all right. So if you had a look at that, you might notice that we have 3 minus x in here, and you also have a 3 minus x in here. So it seems to me if I took the 3 minus x out and leave everything else inside, 3 minus x minus 4x, okay, then I'm already nearly there. So my 3 minus x is okay. Now what about this part over inside here? And that leaves me with 3 minus x and 3 minus 5x. which is exactly what I want, and over root 2 root x. This is exactly what I was trying to show. And the second part of my question was to find the x coordinates of the points in that equation where the tangent is horizontal. And so the tangent can only be horizontal when dy on dx is 0, and this is our dy on dx. This equation can only be 0 if the numerator is 0. In other words, only if 3 minus x is 0 or 3 minus 5x is 0. That will mean that x has to be 3, or on this side, x has to be 3 on 5. And the last question, for what values of x is dy dx undefined? And dy dx will always be undefined when the denominator, which happens to be 2 root x, is equal to 0. That will mean that x, that is, when x is equal to, x is equal to 0. But notice also that we have root x. Now, if you have root x, that means the x cannot be negative. So also when x is less than 0. So altogether, when x is less than or equal to 0, dy dx is undefined. Okay, I hope this was helpful, and if you did find it helpful, then please subscribe to my channel and you'll be notified when the next video comes out. 2 root x.